class, so today we're going to talk about pie.
Oh yeah, that's great. I've been starving. What kind of pie are we having?
No, not that kind of pie.
Oh, so you mean like pie bonds in chemistry. Man, why are we talking about chemistry and math?
No, not this pie. This pie. You know, like the mathematical constant, 3.14, find the area of circles and such?
What are you talking about?
Alright, looks like I have to get into this. Pi is the ratio of the circumference of a circle to the circle's diameter, and is considered a mathematical constant. Pi goes all the way to Archimedes. It was conducted in the first theoretical calculation, and it was approximately this over here. 223 over 71 is less than pi, but pi is less than 22 over 7, which is the smallest fraction that we could get it to. That doesn't make sense, but whatever, I'm a teacher. Anyway, Archimedes proved that the existence of pi by using hexagons, like I did that, yeah. So, the foundation, he calculated the perimeter using that right there, and he also gave the perimeter to the diameter as a given circle, which is the estimate of pi, circumference over diameter, which is right over here. So in 1761, this guy named Lambert proved that pi was completely irrational, which means it can't be shown as a ratio.
Irrational as in like can't be written as a ratio of integer numbers?
Correct. And in 1882, Linderman proved that pi is transcendental.
As in, it's not going to move any algebraic equation with rational coefficients. Get it.
How did you know that?
I'm smart, duh. Of course I know what transcendental means.
Whatever, it's correct. And also, he also proved that you cannot square the circle, people.
Interesting.
Okay, so going back to squaring the circle, the first guy that tried to do that back in Greek times was Anaxagoras, which this guy was so persistent. Anyway, the British as well as the French, because there were so many attempts to actually discover the, may I say, impossible to submit their theories because it was not possible.
Oh, so pi goes all the way back.
Yeah, I'm sure you used it in your past math classes.
Oh my gosh, yeah, I remember. In order to find the area of a circle, you have to use a equals pi r squared, right?
Yes, you finally understand the concept of it.
So pi is just a very complicated number. Like we use it in our daily math problems. I remember in IB math last year, we used it for like cosine, sine, and tangent, and we use that little circle chart. Yeah, I remember that. Got this.
Okay, also, in order to use pi, we have two very important formulas. One is the Leibniz formula, as well as our Wallace product that we have over here.
Sounds a bit complicated, but yeah, I kind of understand. It's better than before.
Okay, so remember I talked about squaring the circle? So here we have it. So a lot of mathematicians back in the day tried to achieve the impossible by taking the area of a square and trying to construct it given the area of a circle. So they tried to construct the same thing using the area of a circle, which equals a question. And they tried to do this with a finite number of steps rather than infinite number of steps, which got disproven by the fact that we found out that pi is in fact irrational. So this and all of this is void.